All right, we're going to go through some of these, or we're going to go through these exam review problems so that you have access to this if you need to see it. All right, we're just going to start with the first one here. In equation, we want to work on the inside first, so we want to distribute this -2, and so I'm going to have -4, 5 minus 2x plus 6. I'm going to go ahead and distribute that -3. Gives me -3 plus 6x. I want to simplify inside first. I'm just going to make that bracket of parentheses since I don't have those parentheses anymore. And that gives me -2x plus 11 equals -3 plus 6x. Distribute the -4. I get 8x minus 44 equals -3 plus 6x. Subtract 6x, and 2x minus 44 equals -3. Add 44, and I end up with 2x equals 41. Divide by 2, and you get 41 halves or 20.5. Either one's fine for that. All right, number 2. I know a lot of people were asking about this in different periods. We want to solve for x, and in order to solve for x, you got to get x out of the denominator, which means you also have to get rid of basically all denominators. And the easiest way to do that is you can multiply each term by xy. When we do that, we get 3xy. The x's cancel, and we get minus 2y equals, the y's cancel, we get 5x. All right, at this point, we need to get all the x's on the same side. Now, depending on how you move the x's and the y, will depend on how your answer will look. So I move the 2y over, and at the same time, I'm going to subtract 5x. It gives me more positives. So I get 3xy minus 5x equals 2y. And now once you get all the x's on the same side, that is when you factor out the x, and then we will divide by 3y minus 5. So I end up with x equals 2y over 3y minus 5 for that. Now, if you moved the 3xy to the other side, everything will be the opposite sign. It is equivalent and it is fine, but it will be -2y, and you'll probably have 5 minus 3y, but those will be equivalent. Either one is fine. Okay, so that's number 2. All right, third one with exponents. I get 2x to the -3rd, y to the 5th, all to the 4th power, and I'm going to go ahead and make this -4x to the -2nd, y cubed, all to the positive 3rd power. So I'm just going to take that negative and move that all the way down. You'll get less mistakes if you do it this way. 2 to the 4th power is 16. Now we multiply powers. X to the -12th, y to the 20th, -4 to the 3rd power, that is -64, x to the -6, y to the 9th. So we do have a positive divided by negative, so overall my answer will be negative. I'm just going to put that in the top. I am going to end up with y to the 11th. 16 divided into 64 will reduce to 1/4. And then when you're done, -12 minus -6 is -6, but you got to move that down below So to get 4x to the 6th in the bottom. So we got negative y to the 11th over 4x to the 6th for that answer. All right, number 4. Okay, we just got a compound inequality with the word and. And I want to solve those individually and then take a look at my answer for my final answer. So I want to distribute this negative 2. And I get 6 minus 2x minus 8 is less than or equal to negative 14. Negative 2x, 6 minus 8 is negative 2 is less than or equal to negative 14. Add 2, I get negative 2x is less than or equal to negative 12. Divided by negative 2, and that's going to flip our sign, and I get x is greater than or equal to positive 6. Over here, I get x minus 4 is less than or equal to 3x minus 36. I'm going to subtract x. Negative 4 is less than or equal to 2x minus 36. Add 36. 32 is less than or equal to 2x divided by 2. 16 is less than or equal to x, which means that x is greater than or equal to 16. This is a compound inequality with the word and. So we want to write our interval and answer in interval notation. So one of them is greater than or equal to 6, which means we would shade to the right. The other one is greater than or equal to 16, which means solid dot, again shaded to the right. We want where they overlap, and so my answer will be from 16 to infinity. Number 5. Okay, we got two things going on. All right. Absolute value inequalities. We talked about less than, and we talked about greater than or equal to. This is going to be an and problem. And you can either split it up, and you can make it 9 minus 7x. And then here's what you do is you flip that as greater than or equal to negative 23. And 9 minus 7x is less than 23. And we solve those. The other way to do this, and this is which way I usually do it in class, is we can just sandwich it in between negative 23. We get the same thing, and 23. Okay, so that 9 minus 7x is greater than. We get the same thing there. We solve this for x by isolating the x in the middle. So I get negative 32 is less than negative 7x is less than 14. Divide everything by negative 7. And then I get 32 over 7. Since I divided by negative, I am going to have to flip both sides. And I get negative 2 over here on the right, 32 over 7 on the left. But we want to always have the smaller number first. So this is going to be equivalent to just flipping this around. Negative 2 is less than x is less than 32 over 7. So x is going to be trapped in between there. So my answer will be from negative 2 to 32 over 7 in interval notation. Okay, so that's what we'll get. All right, this is going to be an OR, grade TOR. You cannot sandwich this when you have to write it as two cases, and we don't want to split it up until we get the absolute value by itself. So I'm going to want to add 3 to both sides, and I'm going to want to divide by 2. Once I get this, now here's the two cases. it's going to be, this whole thing is going to be greater than or equal to 10, but the other thing is going to satisfy it is if that inside the absolute value is less than or equal to negative 10. So we're going to have two cases. And now I just want to solve these, and it's going to be an OR problem. I get 2x is less than or equal to negative 6, which means x is less than or equal to negative 3. Add 4, and I get 2x is greater than or equal to 14. Divide by 2. I get x is greater than or equal to 7. If you want to graph these individually, less than or equal to negative 3, greater than or equal to 7. Since it's an OR, I need to take all possible answers together, and they don't overlap. So this is going to be negative infinity to negative 3, bracket, union, 7 to infinity, with a bracket on the 7. So that will be my interval notation for 5b. All right, number 6, solve. You got a quadratic. It doesn't matter how you solve it. Okay. But my first look is factoring, but what multiplies a negative 3 as a negative 1? Nothing works. So if it doesn't factor, you get two choices: complete the square or quadratic root formula. I tend towards quadratic root formula. It doesn't matter which one we use. Negative b plus or minus square root b squared minus 4ac all over 2a. So a is 1, b is negative 1, c is negative 3. So I'm going to get the opposite of negative 1, which is 1 plus or minus negative 1 squared minus 4 times a times negative 3 over 2a, which is 2 times 1. So I get 1 plus or minus, that's going to be positive 1 plus 12, square root of 13 over 2. Nothing really I can do after that. So I'm going to leave that, and I get my two answers. 1 plus square root of 13 over 2, 1 minus square root of 13 over 2. You could write as plus or minus, that's fine. I just split it up just to emphasize that there's two different answers. All right, what number was that? That was 6. All right, 7. We got a radical. We got to solve for y and see what makes this true. We're going to have to square both sides. Don't forget, you always have to check when you square both sides any answers for extraneous solutions. So this is going to be one of those cases. So we're going to take, once the radical is by itself, which it already is, we can square. And you have got to treat this, the whole side has got to be squared. You cannot square individual pieces, the whole thing, which means you're going to have to FOIL on the right. I get 3y plus 1. When I FOIL, I get y squared. I'll end up with minus 2y plus 1. I'm not going to go through that whole thing. And now you take a look and you got to evaluate what type of equation we have to solve. We do have a y squared. We won't be able to get rid of it. So I am going to set this equal to 0. Now when I do that, that gives me 0 equals y squared minus 5y. Those add up to 0, which is fine. So we got a quadratic. You can do quadratic formula, completing a square, but factoring will work. Even though I don't have a constant here, we have a GCF. And so I can take out a y. And now I simply have y times y minus 5. And then to solve it, I set each of those equal to 0, or figure out what will make each of those 0. So I get y equals 0 and y equals 5. Now, you test those. If I plug in 0, I will end up with 3 times 0 is 0 plus 1. I end up with the square root of 1 equals 0 minus 1, which means 1 equals negative 1. That is not true. So y equals 0 does not work. Y equals 5 will work. I'm not going to go through it. You can do that on your own. So we will get y equals 5 as an answer. All right, number 8. How many gallons of 20% orange juice should be added to 12 gallons of 60% orange juice to make a drink that is 40% orange juice? Okay, so you can do a chart. I do have a chart on my answer key with the worked out work, but I'm just going to set up the equation. We want to figure out how much pure orange juice in each case, and they have to add up to be the same. So we says how many gallons of 20% orange juice. So I don't know that. So it's going to 20% is 0.2 times x, which is our unknown amount of gallons, should be added to 12 gallons of 60%. So you take 0.6 times 12 to make a drink that is 40% orange juice. So we want this to be 40%. Well, what you are doing is you are adding x to 12 gallons of 60%. And so you have got to make this x plus 12 here. And so I get 0.2x plus 0.6 times 12. And I get 7.2 equals 0.4x plus, and now 0.4 times 12 will be 4.8. Subtract 0.2x, subtract 0.2x. 7.2 equals 0.2x plus 4.8. Subtract 4.8. And I get 2.4 equals 0.2x. Divide by 0.2. You get x equals 12. Well, we started out with, we used 12 gallons of 60%. It's not always going to be the same. Okay, don't assume that. That's just coincidence. But we do need 12 gallons of 20% OJ. Number 9. Determine the equation of a circle in standard form. Specify the center and radius. All right, for a circle, we just finished ellipsis, hyperbolas, and parabolas. Circles is a form of a conic. Remember, though, that is x minus h squared plus y minus k squared equals r squared. This one does not equal 1. We can't have any constants in front of here, but we just equals a number. If it's not in this nice form, we're going to have to complete the square, which we've done multiple times. So group your x's together. So it'll be x squared minus 6x, and we are going to have to complete the square here, plus y squared plus 8y. Again, we're going to have to complete the square, move our 10 to the other side, and then you're going to have to balance out the left side and the right-hand side. All right, half of negative 6 is negative 3. Square that, we get 9. It's not being affected, so we add 9 over here. Half of 8 is 4. Square that, I get 16. And I factor. I get x minus 3 squared plus y plus 4 squared. Negative 10 plus 9 is negative 1 plus 16 gives me 15. Center. 3, negative 4. Radius will be the square root of this number. Square root of 15. So we don't know the square root of 15, so you can leave that. That is fine. Center, 3, negative 4. Radius, square root of 15. All right, number 10. All right, some composition of functions. F of g of negative 3 and then g of f of x. All right, so f of g of negative 3 means you plug negative 3 into the g function. You take that answer and plug it into the f function. So g of negative 3 is going to be 2 times negative 3 squared plus 7. Negative 3 squared is 9. That's 18 plus 7. We get 25. Now you're going to take that and plug that into the f function. And so it's going to look like 3 times 25 minus 5. 3 times 25 is 75 minus 5 is 70. So that is our answer for f of g of negative 3. It will be 70. All right, for B, we're just a general f of x. We don't have a specific number. We had negative 3 here. We just have g of f of x, which means we can rewrite it in this format. That means we plug in the entire f of x function in for any x's in g of x. Well, we only got one. So it's going to look like 2 times the quantity 3x minus 5 squared plus 7. And now I guess you have to simplify it. You do need to FOIL there. So, that'll be 3x minus 5 times 3x minus 5. And you're going to get 9x squared minus 15x. Minus 15x is minus 30x plus 25. Don't forget your plus 7. It still needs to come down there. Distribute your 2. That should not be 57. That should just be 7. It will become 57 in a minute. So when we're done, we get g of f of x equals 18x squared minus 60x plus 57. You do not need to try to factor this. I just noticed you do have a GCF of a 3, but we do not need to take that out because there's nothing to cancel with. You can leave that. So here's f of g of negative 3 and then g of f of x. And now for this video, we're just going to stop at number 11. F of x equals 2x squared minus 5x plus 9. Compute this. You will be given this in this exact format on the exam if you do have this problem. So you don't have to memorize that format. All right, f of x plus h. That is the first one that we're looking at. Remember, that means that you are going to replace x plus h in for each x. So it will be 2 parentheses x plus h quantity squared minus 5 times x plus h plus 9. So that is the f of x plus h minus f of x minus, and so you just take the exact original equation, 2x squared minus 5x plus 9. All of this is divided by h. Now we need to simplify, combine like terms. This x plus h squared, that is a FOIL. So it's going to be 2. And when you FOIL it, you get x squared plus 2xh plus h squared. And now I'm going to distribute my negative 5. It gives me minus 5x minus 5h plus 9. Distribute the negative, so I get minus 2x squared plus 5x minus 9 all over h. I'm going to distribute that 2x squared plus 4xh plus 2h squared minus 5x minus 5h plus 9. I don't need any parentheses anymore after distributing that 2 and distributing the negative sign in the previous one. So I get minus 2x squared plus 5x minus 9 all over h. At this point, we want to combine like terms. And when we did this earlier, I mentioned that everything without an h should cancel. 2x squared and minus 2x squared. Negative 5x and positive 5x. Positive 9 and negative 9, which will leave us 4xh plus 2h squared minus 5h all over h. Also, if we do everything right, everything should have an h, which means we can factor out an h from each term. And then the h in the denominator will cancel with that h. And then the final answer is 4x plus 2h minus 5. That's what we call the difference quotient. Whoops. For that. Okay, I'm going to end this video here.